All right, guys, I think it's time. Looks like everybody made it in. So, there we go. Yep. Welcome to the Binary Ninja versus IDA Pro. We weren't sure exactly what to call it, so we said something about malware, but it's really about checking out the tools that are available to us as reverse engineers, malware analysts, vulnerability researchers, software devs that are looking at closed-sourced apps. There's a lot of reasons why you might want to reverse engineer something, and there's a lot of different tools, kind of feathers in our cap, that we can use to make that happen. And some good friends of mine that I know very well, Jordan and his whole crew here. Rusty, you guys want to stand up? So stay standing, stay standing, stay standing. I just want to say a few things while they stand. I'm going to embarrass them just a little bit. I've been in the security research scene a long time. And I don't know very many people in this field that would have the gumption to try to create a software product that would compete head-to-head with something like IDA, which is kind of a, kind of an icon in our field, and sell it for half the price or less. So I would say give them a round of applause because I think it's amazing what they're doing. Okay, so who am I, by the way? I'm Jared DeMott, CTO of Binary Defense and founder of VDA Labs. Josh and I both trained here at Derby. We had some training here this year. A great class, AppSec, fuzzing, code auditing, reversing, advanced security, hacking, all that kind of good stuff. So if you want to check that out, feel free. Josh Stroschein is here with me. We had another fellow, Josh Blake, do a little bit of work as well. Josh is a CSU, so we've both done, oh Lord, here it comes. Thank you. It feels festively warm. It's like warmer than even just room temperature warm. It's like been in the microwave warm. Thank you, Dave. If anybody wants this after, it'll be right here. Okay, so back to where I was. We've worked with a lot of different organizations, DSU. We both have done stuff with Bromium. He's done some malware analysis for them. So suffice it to say, we have a lot of experience both in product security, vulnerability research, malware analysis, you name it. We've kind of done it. I even have some courses up on Pluralsight, and those folks are here. If you want to, where are my Pluralsight friends? They're right here. If you want to stand up, say hi, give everybody a wave. You can check out the course there. So, Binary Ninja. If you go to the website and you can check out all the different features, we're not going to, I'm not a paid spokesman for Binary Ninja, just so you know. I tried to actually do a fair analysis between IDA and Binary Ninja. So, it is what it is. If I mess up stuff, miss stuff, Jordan's right up here after. You can come find him. He's got stickers. You might even be able to get a t-shirt, but I don't know about that. That's probably going to take a lot of convincing. But so we're not going to go through the whole list of every feature that's in each product and really try to, go exhaustive on that. Today's learning was more about, IDA's kind of ruled the roost, right? At least in my perspective anyway, for a spectrum of activities. So what about this new tool? Does it have a shot at doing what IDA does? And so that's kind of what I was interested in learning about. First of all, the pricing's a lot more straightforward on Binary Ninja. It's a lot cheaper. It's a lot easier to understand. It's just got a very simple way to understand it. If you go and look at the pricing for IDA Pro, go to the website for Hexrays and try to figure out how to buy IDA Pro. It's like you have to figure out which zone you're in, the Eurozone, and like all this stuff, right? And what you want to like name license or floating license, and it's really kind of confusing, I thought. But anyway, you'll find out at the end of the day that it's quite a bit more, particularly if you want the decompiler and all the other sort of add-ons, and you have to buy it for each architecture. It doesn't just work on your Mac or Windows or whatever, like you have to buy it separately for each. So I would say Binary Ninja is definitely better in that sense. It's just more easier to buy and easier on the wallet and, that whole thing. In terms of the interface, pretty similar. Just open it up. You can drop a file in it, whether it's an executable or an alpha object or whatever it may be. Just throw it in IDA or Binary Ninja, and you'll get a similar sort of look and feel to the graph. So a lot of the hotkeys, if you're familiar with IDA, I think the Vector 35 folks intentionally made some of the hotkeys pretty similar so that you can transition your skill set from IDA over to Binary Ninja. Like if you hit the space bar, for example, you go to the flat view versus the graph view. So those kind of existing knowledges you have already there, and that's great. I think that definitely eases a transition if you're interested in learning the tool. Some places where IDA is a little bit more mature, because I mean that's the if too long didn't read, right? If you want the takeaway from this talk, it's like, hey, Binary Ninja is awesome, but they've only been selling it for a few months, where IDA's been in the market a long time. So it's going to have a few extra things. For example, like particularly on Windows, it seemed to us anyway that like finding main and symbols and things like that, IDA was a little better at for now. I know Jordan's got a whole roadmap of where they're at and where their features are coming and where it's going to be in the future, and I think you can stay and talk to him about that if you want to know exactly where that is. So on ARM or ELF or Mac or whatever, maybe they're more comparable. Maybe Binary Ninja does a better job there. We didn't try every combination of situations, but at least if you're in probably the highest percentage of reverse engineers, there's ones that do reversing for finding vulnerabilities and for closure, all that stuff. But malware analysis on Windows is a pretty big piece of what IDA gets used for. So it does have some nice capabilities. IDA probably wins there for now in terms of being able to identify functions like main and start you there instead of starting you in start. Also things like identifying common types, common features, functions. For example, if you're really kind of down in the weeds, if you're used to looking at the bits and bytes of things, this is from control flow guard. So if you're looking at a binary that's been compiled for Windows 8 or Windows 10, and it's got this new protection that Visual Studio 2015 and higher gives you called CFG, IDA recognized that this call is to a call to going to check to see if the pointer is a valid pointer or not, where in this case Binary Ninja didn't recognize it so well. So you could name it, you could definitely type name it and stuff like that, but IDA did more in terms of functions and all of that stuff. So, and that's to be expected, right? A tool that's been around for a long time costs a lot more versus a tool that's a little bit newer in the field. You kind of expect that sort of difference. So in terms of the interface views, the linear view, the hex view, the graph views, pretty similar. The look and feel of Binary Ninja is a little cooler. It's got kind of the dark background and all that. You can customize that in IDA too if you want. So you can kind of get similar looks and feels, I would say. The tabs is something we really enjoyed in Binary Ninja. So if you're going to open multiple programs, multiple DLLs, whatever you might have, you can have it all in your main Binja window. I don't know if Binja is a word. Is that a word? Can we say Binja instead of Binary Ninja or BN? Binja? Okay. So where in IDA you have to open up each DLL and stuff separately in a different program. So that is a little more clunky in IDA. So I like that about Binja, if you will. The log output on the bottom is pretty similar. You get a bit of a similar thing, although I like the scripting view of Binja better. You've got a kind of a window dedicated to the interactive Python interface, which is much cooler, much nicer. I think I like that a lot better. The auto analysis and the UI and all of that when you first load a program, in my experience, was faster in Binja. So if you put a big fat DLL like mshtml.dll, if you've ever done that, put that DLL in IDA and see what happens. You end up, it's like go get a cup of coffee, right? And maybe, I don't know, you could ask Jordan again why exactly that is. IDA's results end up a little better, right? You get more, it finds things better, and like some things get named better. So it ends up a little better, but it's a lot slower. The UI is a lot more responsive and a lot faster in Binja. So I liked that. Pros and cons there. Cross-referencing views are still there, so you can find the string view. Josh is going to do the demo part, so he's kind of giving you the meat. I'm giving you more of the overview. He's going to actually do a demo of showing you the look and feel of Binja versus IDA, and looking at a script. We wrote just a simple script, and there's nothing really special about it. It was for a piece of malware, and it's basically how hard is it to write it for IDA and how hard is it to port it to Binja, basically, was kind of our task, just to see if it was comparable. So you'll see a lot of that. Like I said, the strings view is there. You can find that. It didn't seem like the cross-references in the strings view was quite as good in Binja. I didn't see that. So there's a list of the hotkeys. I'll just leave that for you. They're pretty similar. So like if you hit G, for example, to go to a particular location, it's the same in IDA or Binja. The patching and modification, I think, is definitely going to be better, especially in the long term, and even now in Binja, because their background is really more vulnerability research. So that's been more of their focus. A lot of the work they've done revolves around, being able to change and patch and shellcode and find bugs and all that kind of stuff. So the patching and modification part in Binja is really top notch. Got a link there to the SEC binary.ninja, and we'll show some other documentation links, but you can find all the documentation on those links as well. So what is IL? And basically, I'm not going to go into a long-winded explanation of it, but it allows for an intermediate view of the assembly so that cool things can be done. So that, the simplification of a new architecture can be added. That's something that Jordan and his team, Binja, they really feel like the IL that they have is going to help them in the long run to create their decompiler, to do a lot of things that they're going to do to not only catch up, but in the long run excel. So the IL that's available in Binja is really exciting. I encourage you to kind of dig deep into that. It's sort of a deeper compiler theory type subject that I'm definitely not going to go over today. It's not a broadly accessible thing. I think it's kind of down in the weeds. But if you, just to take a look, like at the very bottom on the assembly, there's a JE, which is jump in assembly, right? Where in the IL, you see it as more of an if. So you get kind of a slightly higher level view of the logic, not necessarily decompiled, it's not in C or anything like that, but you get a little bit more intermediate representation, which we thought was cool. Same thing in ARM, if you look at ARM of a jump versus just using the words if, it's a little more accessible maybe. So we like that, we thought that was pretty awesome that you could get that. One of the common questions that people ask me is, I heard you giving a talk on Binary Ninja. What architectures does Binary Ninja support? You can go to the website and find out. And quite a few, like the x86, the ARM, MIPS, 6502, but definitely not as exhaustive as a tool that's been around 20 years, right? If you look at the list of things that IDA supports, it's like the Qualcomm Snapdragon, the Game Boy, Fujitsu, like all these crazy architectures, like I don't even know, right? Like I don't find myself reversing that a lot, but if you do, then IDA might be the tool in that case, right? I mean, it makes sense, come on. So, this is kind of where we begin to get into the meat here. So the plugins, we wanted to take a look at what does it take to write one, what's the interface look like, how do you transition an existing IDA plugin to a Binja plugin, and that's going to be an important thing that needs to happen, and I'm sure that's something that Jordan Rusty and his crew would love your help, your support, get the community involved in that, because what happens is IDA has a lot of this, right? If you're a malware author, a malware analysis analyst. If you're a malware author, you might do this too. I obviously need my Starbucks. If you're a malware analyst, you probably have some plugins for IDA that help you do your deobfuscation techniques and all this stuff, especially if you're doing runtime analysis, right? And that's one place where IDA definitely excels right now, is they have a debugger built in where Binja doesn't. So if you're going to do runtime stuff and you've got special plugins and you're doing it because you work on malware on Windows, IDA is going to be your thing. But that can very easily change, and one of the ways that can change is the Vector 35 group, they've got a vision for a whole community around plugins that as those begin to port and change and come to be in Binja, they'll be a lot more organized, they'll be a lot more accessible, they'll be easier to write, they'll be faster. This whole sort of App Store idea, I guess, is Jordan's vision, I think, for what he wants to do with plugins for Binja. And that's something right now that IDA doesn't really have. It's pretty much like you got to go out and surf the interwebs and troll some shady sites, and then I found this plugin. Like they're not always easy to find in every case. So that's the scoop with plugins right now. So there's going to be some porting that needs to be done in the short term for sure. So I'll let Josh go over that, the APIs, and take a look at that. One of the other things that's cool about Binja is it has an undo, which is not something that IDA's ever have. So we thought that's something that's missing for a long time. So we got to throw that in there. So on that note, I'm going to turn it over to Josh, and he's kind of get into the weeds a little bit.
Thank you, Jared. I spent all night while you guys were partying making that video, so I hope you enjoy it. My name's Josh. I'm going to have two jobs today. One is to hopefully explain or convey a little bit more of the technical, not going all the way into the weeds, about the script, the malware sample, the problem that I set out to tackle for this particular demo use case. The other thing I need to do is suck all the humor out of the rest of the afternoon. So bear with me here as we get a little bit deeper than the overview. So what I looked for was just a simple sample that exhibited some characteristics, something that I find myself doing over and over again. And one of those, and what I found was a sample, really just a common dropper, but it was dynamically resolving the API calls that it was making. So I was finding a bunch of call to a register, so an indirect call, and I figured out very quickly where it was obfuscating. I had a bunch of hashes in order to resolve the modules and eventually then the APIs within those modules to make those calls. So finding those addresses, putting them into the register, of course, then making that call. As an analyst, that's something it's a bit frustrating because it slows us down. We don't understand exactly what that sample is doing until we can figure out what those calls are. So I thought that would be a great use case, especially something that would be achievable, maintainable to set out and do within Binary Ninja. Or actually, I started with IDA, an IDA Python script, and then converted it into Binary Ninja. Here you can see the MD5, the virus total score. It's also in our GitHub account, so we'll have a link here at the end of the slides if you're interested to pull down not only the sample as well as the scripts. Those are available. First, had to unpack it. So, of course, that's usually one of the first things that we have to do with malware. And nothing too extravagant there. I have a fairly simple, I think, or fairly routine approach to deobfuscating and then getting that unpacked binary out. That is typically, I've either watched the process creation and kind of get an idea of what it's doing, first to determine if it is packed. And then the other is put it in a debugger, probably put some breakpoints on the memory allocations, and then just track those memory allocations until I find in memory the PE header signature, so that I know I can dump that memory, and that's likely my unpacked binary. I don't spend a whole lot of time trying to figure out how it was packed, so in this case, definitely not dealing with any of that. It's avoiding strings, it's avoiding imports, so all of the calls are dynamic. So once this sample was unpacked, it was just a bunch of instructions. There was nothing in there that gave me any insight into what it did without further dynamic analysis. How it did that was, again, fairly straightforward. So I think the value in a script like this is that it's something that I'll be able to use or hopefully adopt over and over again here as I look at and analyze more samples. So it has kind of two main portions to it. The first is to dynamically locate the module that it wants to find the API calls in, so kernel 32, for example. So it's going to walk the PEB in order to find the currently loaded modules for that process. Once it finds those, the ones that it's seeking anyway, then it has a base address. From there, it can use the PE file format to start from that base address and figure out where the exports are. The exports then are essentially hashed compared to the hashes that are hard-coded in the sample, and it has the address from there. So then it can populate essentially a destination array, an array of addresses that it knows which one is which in order to make the calls a little bit later on. Here you can see no strings, no imports, no exports. I'm very sad. And this is a sample here in the disassembly view of the problem. So we've got this push, pop, and then call. So we know that that D word is going to be what's pushed into or eventually moved into that register, but I don't know what it is. Okay, as Jared alluded to a little bit earlier, I really had, I think, two options in a normal workflow, as I started to figure out what these registers are. I could continue with a static approach. In this case, the sample was relatively small, so it probably would have been a lot quicker to just dynamically do it. That is, maybe set a few breakpoints at a lot of these indirect call sites and then comment and change the names of the symbols as I went. But that wasn't really the point. I wanted to solve this statically in order to produce the script, so I went that route anyway. This also is where I started to have to deviate a little bit of my workflow. So normally with IDA Pro, I'd set the breakpoints, I'd connect it to my local Win32 debugger or WinDebug, and I'd go ahead and I'd start debugging. Integrated, it's nice, I can see the values in those registers then as I hit my breakpoints, and then I'm able to add comments or rename symbols as I go. With Binary Ninja, I had to bring up a debugger or just use IDA. So a little bit of a difference there, just because there isn't that integrated debugger support at this time. I've seen some plugins, or at least one, that is trying to bridge that gap. I'm sure there's probably a roadmap for it as well, but just a little bit of a deviation. So the next part was to implement the functionality, to figure out the functionality and then implement it statically. So going through, this is one of the first calls. I identified essentially a start and then a main into this program. And so I jump right ahead. This is the main method, or what I considered main. This is a really good example of how this process and this sample work. The first function is going to resolve the module. The second is going to resolve all the APIs that it wants to call from within that module, and then that last call is going to be the indirect call to whatever API that it wants to make a call to. Some of you might recognize just by the signature of that, those pushes before that call, that it's a virtual alloc, but we'll see that here in just a moment. The first thing it does, you can see the very first instruction there listed in that screenshot is the hash. So that's the hard-coded hash. It moves into a register. So with these next two functions, all of the parameters are essentially being passed via register. So EBX is loaded with that value. That hash walks the PEB, returns in EAX the value of the address of the module that it's after. We can see later on that as that next function is called, EAX is moved into EBP. So that's how that knows what base address, what module to start looking for to try to resolve those calls, those addresses for the API calls. The next two instructions after the first call, LEA ESI and LEA EDI, that is the addresses for the source. So it's an array of D words, essentially those hashes that are going to be compared. They're going to be dynamically generated and compared to find the address. And then the EDI is going to be the destination. So it's another array that after the sample has had the ability to run, it's going to be populated with addresses. Okay, when that returns then, you can see getting to that last call, there's a push D word. So one of those elements is pushed on the stack, popped off the stack, moved into the register that we're going to call from. And those were my notes, just in case I forgot that. Okay, so the functionality between the two were really rather similar. So they had a very similar approach in far as how they actually generated the hash. So instead of going through both of those, I decided to skip how the module hash was created and just jump right into how it actually resolved the API. So at this case, when that function is called, that was the second call that we had from the previous slide, we're assuming, passed via that EAX register, that we have the base address for a module. So it's able to then parse that structure. It's a DLL, it's a PE file, define those imports. It has, once it has access to all those exports, not the imports, but the exports, it's going to compare those. It's going to generate a hash for each export by name. And it's just going to simply do that by iterating over each character of the export name, character by character, doing a little bit of bit manipulation along the way to eventually create the hash. As it gets to the end of the name, the end of that string, then it has the hash. That hash is then compared to one of those that is hard-coded, and if the hashes are the same, then it returns the address. So it's found the address of the export that it wants to call. If not, it continues on, and it does this for every single value, every single hash that it's looking for, resolving those as it goes. So the scripts, we'll take a look at the full script in just a moment. I wanted to take a couple of slides here to explain in a little bit more detail kind of the core differences between the two scripts. And I found as I not only wrote them, but Jordan and his team were very gracious to give me some feedback on my first and admittedly rather rough draft of the script. They see that they really come together and there's a lot of overlap between the two. So with this is the binary ninja script. And you can see with that first function, what we're getting is essentially a function object. And I'm passing it in the address of where I want to start. So that's the hard-coded address that I consider to be my main function. From main, I'm going to go through each block and each block of code. And with each block of code, then I'm also going to get all the instructions of the IL for each instruction within that block. From there, it's really just a matter of looking for the call target. Because what I decided to break on so that I could figure out what those and resolve all those API calls statically is when I saw that call to that very first function. So I've just called it module, resolve module API address, resolve API address. So with this one, actually I braked on the address for the resolve to the API. So the second to last call. And the reason I did that was because with some of these instructions a little bit later on, you'll see that when I get to that call instruction, then I can actually ask it for the values of the registers that preceded that. And this was a really good example of that because I knew those registers were going to have static values moved in. So I was able to query the register state at that call instruction to get those values. So first thing, resolve the module by hash. Right? I generated the hash function looking for and determining what the actual DLL was. And in the static case here in these scripts, I didn't actually need an address. I'm not dealing with the virtual address space here. I just needed to know which DLL it was so that I could later on parse that PE and walk the exports. Once I found it, the next thing I did was call the resolve module APIs. So that was the function then that was responsible for parsing that PE, generating the hash for each export, and then comparing it from those hard-coded hashes in the original sample. As that resolved those, I knew the name, I could update the symbols, and I had better visibility into what the sample was doing. Okay, same section in the IDA script. Not a whole lot different here, slightly different functions, of course, a different API, but same process. We're going through each instruction. I'm looking for the call. Once I find the call, I'm able to pull all the information I need in order to resolve those APIs. With this one, though, I had to adjust just a little bit, in that I looked for not the call to resolve the actual API, where I had the name of the module, but where I called the module. Because once I knew I was at that point, I could look at the previous instruction to get the module hash. I could go then 2 instructions beyond that, or iterate, and find the destination and the source of the hashes as well. So once I found that call, I had everything I needed from there. So a slight difference in the 2 scripts just based off of how I was able to walk back and forth from the current instruction. As I mentioned, this is where I felt I was able to really simplify my script. My first time through, what I ended up doing was I didn't know how to effectively get those values from those registers. I found that call site and I wanted to get ESI and EDI and EBX and these values that were for previous instructions. And I wasn't quite sure how to do that. So what I ended up doing my first time through was simply creating a list and appending all these IL instructions to the list and then keeping track of some sort of a counter so that when I knew I got to that call site, I could go back in my list, pull out the IL, pull out the values. And that bloated the script quite a bit. Finally, it was pointed out to me through some help that I could just query those registers. So you can see here, that's what this is doing. So that main.getRegisterValueAt, main was our function. I pass it the address, I tell it what register I want, and then I tell it to give me the property of value. And now I have both the source and the destination. So those addresses that I was looking for within this particular binary. IDA, similar concept, but I had to use next head, previous head. So I just had to move from the current instruction that I was on, using that head object to go back and then also to increment so that I could get those values. All right, so at this point, probably the scariest for me is to do the demo. Demo as well as walk through the scripts. Is that even legible? Yeah, okay. Okay, so I'm going to try to compare these side by side and just point out a few things here along as we go. You can see hopefully that there's quite a bit of overlap. There's quite a bit of similarity between the two scripts. So imports, the addresses are a little bit different, and they are different because I explained I have a slightly different approach as far as determining when to trigger the functionality of my script. I had a heck of a time finding any real good bit manipulation functions, so I had to find this rotate left implementation on the internet, and I kept a source there. I have two functions to help create the module hash, create the
Hi folks, Alan Geek here. Unfortunately, one of the video capture devices flaked out on us, so we don't have any audio for the rest of the talk, but hopefully we got most of the content here. Sorry for the problems.